Hello. Today, we want to talk about functions, but first, start talking about relations. So, today's our discussion is entitled Relations and Functions. So, our goal, as we see here, says we will understand functions and relations, the differences between them, how they're alike and how they're different, and also understand how the vertical line test helps us determine whether or not a graph is a function. We'll talk about that in a moment. So, relation, let me just read this. It says, a relation is a correspondence between two sets of things. Correspondence basically meaning an assignment. So the first set we're going to call X. We'll call that set the domain, and the second set we'll call Y. We'll call the range. In a relation, each element in the domain corresponds to at least one element in the range. We can think of the domain as the set of inputs and the range as a set of outputs. For a relation, one input can have more than one output. So what this means is we have the group of a set of things, numbers, names, people, whatever, called X. That's what we call our domain. Those are our inputs, or X's. Then we have another set of outputs we call the range. Those are our Y's. So the relation then, we take inputs into our relation and make some assignment between these inputs, between X's and Y's. Then we get the outputs of those assignments. That's what a relation is. Now, it says we can write a relation and a function as well, as we'll see, different ways. There's an equation, a table, a set of ordered pairs, or a graph, or even as what's called a mapping. We'll look at some examples of those in a moment. Then a function is also a relation. I'll just read this as well. Is a type of relation in which each element of the domain corresponds to only one element of the range. In other words, each input has only one output. If a function is called f, named f, then for an input x, the output y is written as f of x. That's how we describe that, how I read that, f of x, where the input is x, and then the function is called f of x, or f, and we read it as f of x. In that case, we call the independent variable y, call x the independent variable, and call y the dependent variable, just as we did with the relation. So in a function, in a similar way, one input goes in. For each input that goes in to our function, make some kind of assignment or change, then only one, for each input that goes in, only one output comes out. So let's look over here to the right and look at some examples of function and relations. So on this side, on the left side, I'm going to create a set of relations. And then on this side, I'm going to make a similar set, a related set of functions. This will help us to understand how functions and relations can be written, and then also the differences between them. So first, let's imagine our first example, let's imagine we're assigning students to classes in college or even high school. So let's say this box, this is going to be our domain. These are our students. This is our domain. These are inputs. And let's say I'm not going to be really creative with the names. So we have Bob, Liz, and Tom. And then our outputs, our range, are the classes they choose. Classes they will attend. So this is our domain, this is our range. Okay. Then relationship then is assignments. Let's say we have our classes, say we have math, history, English, and let's say music. Now, let's say Bob takes a math class and history this semester, and then also takes music. Okay. Maybe Liz is a part-time student. She only takes English. And then Tom takes both a math class and a music class. So those are the assignments that are made. Once again, these are relations. So in this case, an input can have more than one output. So Bob can be assigned to more than one class at a time. So can Tom. Or Liz can as well, at least she's only taking one right now. That's a relation. That's not a function because, once again, the inputs have more than one, some of the inputs have more than one output at a time. Now, let's make a function over here. How about we use the same three students? once again, this is our domain. Let's say once again we have Bob, Liz, and Tom. And this time we're assigning them for a function to dorm rooms. So maybe they're going to live in the dorm. So this is our range. In this case, this has to be a function because it doesn't make sense to assign one person to more than one dorm room. Let's say we have this one dorm has, looking at just 3 rooms, room 1, room 2, and room 3. Okay. Say we assign Bob to room 1. Let's say we assign Liz to room 3. And then let's say we assign Tom also to room 1. They're going to room together, Bob and Tom. Okay. Now this is a function because in this case, each input goes to only one output at a time. Okay. Now, if you notice these two, Bob and Tom go to the same output, they have the same output. That's fine. That's still a function, but we just can't have more than one input. For example, if I try to assign Bob both room 1 and room 2, that would no longer be a function, also wouldn't make sense. That's one difference. This is also something called a mapping. So basically just kind of a picture, a way in a picture of explaining how inputs are assigned to outputs. Let's look at a few other ways functions can be represented. This time let's look at a table. Let's say I have a table, an X and Y table. Let's say 0 goes to -3. So my X's are my inputs, my Y's are my outputs. 0 goes to 3, 1 goes to 4, 2 goes to -1, and 1 goes to 7. Okay. Now, so for each input, I have an output, and then say, so for the input of 0, its output is -3, and so forth. Notice here, 1 has 2 outputs. 1 goes to 4, 1 also goes to 7. Okay, that's a relation, but then that wouldn't be a function. I can modify that for it to become a function by, in a sense, just changing 1 or 2 numbers, just one number, in fact. So let's say that 0 still goes to -3, 1 still goes to 4, 2 still goes to -1, and this time let's say that 3 goes to 7. Now this is now a function because each input goes to only one output at a time. So these numbers make up my domain, these make up my range, and each input goes to only one output at a time. That makes that a function. Okay, let's look at a couple more examples. This time let's write a function as a set of relation to a set of ordered pairs. Think of like X and Y coordinates. So let's say we have -1, 3, 0, 4, and then it's going to have -1, 2. Okay. So here my domain is made of my X coordinates, my inputs, -1, 0, and -1, and or just -1 and 0, since -1 is repeated. And my range are my set of outputs, 3, 4, and 2. Once again, this is not a function because -1 has 2 outputs. It can go to 3, it can also go to 2. Now, I can also modify this slightly to make this a function. Let's say -2 goes to 3, 0 goes to 4, and -1 goes to 2. Okay. Now, this is now a function because now each input goes only one output at a time. -2 goes to 3, it only goes to 3. 0 goes to 4, it only goes to 4. -1 goes to 2, it only goes to 2. That makes this a function. It's still a relation. There's also now a function where this one was not, relation was not a function. We can also write functions in terms of like equations. That's a little harder to see how they're functions and not functions. But you can also think of graphs. So actually, let's start over here. Let's make a graph that's a function. So here's my X, my Y-axis, my X-axis. Let's say I have a parabola. Looks like this. So this is my function. Call it Y, I may call it f of x, or my function f. Now, what makes this a function is that if you pick any x along the x-axis, it only corresponds, only goes to one y at a time. For example, I pick this x right here, then the point on the graph it goes to is right here, x and y. It only has one output, one y at a time. And that's true of any point, any x you want to pick, that will be true. that makes this a function. Each input goes along one output at a time. Now, let's come over here. See, here's our x and y axis. Let's also make a parabola. This is actually a parabola turned on its side. Now, this is not a function. It is a relation, but not a function. Which is, for example, if I pick x right here in a similar way, it has one output here, this x and this y, y1. But down here, it also has another output. For this x, it also goes this y down here, so x, let me call it y2. So that makes that not a function, okay, because each input has more, or not each input, but this input has more than one output, okay? That makes it still a relation, but no longer a function. In the same way, these things were relations, but not functions, also had multiple outputs for one input. And that brings us to our next idea, how I can tell that a function is not, or graph is not a function if I draw a vertical line through it and cross it more than once. That's what would happen here if I do a vertical line through this one. That brings us to our next idea called the vertical line test. Let's look back over the left. I'll just read this. So it says a vertical line test. We can determine whether or not a graph is a function by using the vertical line test. If we can draw a vertical line through a graph and touches the graph more than once at any point, then the graph is not a function. When a vertical line touches the graph more than once, it means that one input has more than one output. So let's discuss that over here. And also let me go ahead and mention this one. So this, come back over here, so say this graph, we say this fails the vertical line test. Well, this one passes the vertical line test. Okay, now let's look at this idea. So basically, a vertical line is a good way of showing that, because if it says if it crosses it more than once, it's no longer a function. Let's look at these graphs here. Some of them I've already looked at. For example, the parabola, I've already looked at this one. This is a function the same if you draw a vertical line through it anywhere, it only touches it once. That means for each x, it only has one output. Same here, y equals x cubed, the same way. I'll draw a vertical line through it anywhere, it only touches the graph once, meaning for any x I pick, it only goes to one y at a time. But just like this parabola on its side here, this is not a function, it fails the vertical line test. Because you see for 1, when x is 1, it has two outputs, 1 and -1. So that's what the vertical line shows. So this is not a function. And the same with the circle. For example, this point on the circle, this x has two different y's it goes to. It's also not a function. It fails the vertical line test. Now, if you took parts of those graphs, like you took the upper half of this graph, or the lower half, this would be a function, or also the upper half of a circle, or the lower half of a circle by itself would be a function, but the whole thing together, they're not. So what we've learned today is basically the difference between relations and functions, how to write, some examples of each, different ways of writing relations and functions, understanding their domains and ranges, and also understanding the vertical line test, and how I can determine whether a graph is a function or not. Thank you.